Good day, my natural science learners. I hope you are keeping fantastic and that you are keeping safe in these difficult times. Now, I hope you are ready today to learn something new. So let's get ready for today's lesson. I hope you enjoy. Grade 6s. Today is the 7th of September and today's topic will be using electrical circuits part 2. Now, let's just remember to write down our date and make sure you write your heading. I would please like to ask you to make sure you have these notes written down neatly and clearly in your book. You may use lots of color. Now, if you have the academic pack, you are more than welcome to stick these notes in your book. Otherwise, you can take this lesson to write them out. Now, please make sure that you read all the information that's in this lesson, and you can even make sure after the notes you read to make sure you fully understand how electrical circuits are used. Please make sure to complete the one question for the activity in today's lesson, and most importantly, remember to rule off when you are done. I hope that you enjoy this lesson. Let's get started. Electrical circuits that produce light. Electrical circuits take electrical energy and they transfer it into light energy. A torch can provide you with light during the dark. And now inside a torch, we will find an electrical circuit that will produce us with light if there is a source of energy on the inside. Now remember, our source of energy would be our battery or our cells. And remember, our battery is made up of different amounts of cells. The circuit is connected to the cells and a light bulb by using conducting wires. Now the best conducting wire we can use is copper. Our light bulbs at home, school, and the street lights are all connected to an electrical circuit. And remember, this is where we will see our mains electricity coming from. Some devices use LEDs to make light because they last longer than a normal light bulb. And of course, they shine brighter than a normal light bulb. We use electrical circuits in traffic lights to regulate the flow of traffic. And remember, different lights can have different meanings. So this is a great way to see how electrical circuits solve a problem and how they can produce light and solve many problems in the world around us. Electrical circuits that produce sound. Some electrical circuits produce sound. And remember, some of the things in the world around us, the system needs to make a sound in order for us to hear what is happening. So sometimes we need sound energy to take place so that we can know what is going on in the world around us. So circuits can also produce sound. And these devices that produce sound transfer electrical energy through a system. And then they produce sound energy, sound waves. Now in grade 4 you learnt about the ear, the inner and the outer ear, and how sound travels through it. A basic electrical circuit is built into a doorbell, and that produces energy to make a sound. So just remember, if someone is ringing your doorbell, it goes through the electrical circuit, so it changes electrical energy into sound energy. Now this sound is made by a small component and we call it a buzzer. Now we do have a particular symbol for a buzzer that you will see in this PowerPoint slide. A buzzer converts electrical energy into sound energy, and a digital clock that is used to wake you up are also classified as a buzzer. So now what I'd like you to do is just look at what symbol we use and in a circuit diagram which shows us that a buzzer is in the circuit. Now let's have a look at electrical circuits that produce heat. Electrical circuits can be used in order to produce heat. So electrical energy changes to heat energy. An electrical heater is a great example of this, where it takes in electrical energy but it produces heat energy and warms the environment that it's in. The heater has an element inside of it that is made from very thin, specially made wires. So that is the element that heats us up. As the electricity flows through these wires, they start to get hot. Other examples of electrical circuits that produce heat are hair dryers, irons, curling irons, and even toasters. Can you think of any more circuits around you that produce heat or maybe even sound energy? I want you to take a moment and write down 2 other things that create a sound using a circuit and 2 other things that create heat using an electrical circuit. Now, grade 6s, I'd please like you to pay attention and watch the following YouTube video on a circuit with a light source and a buzzer. Remember, you do not need to make or build the circuit on your own, as it is not necessary for you to buy all the different components. Now, what I'd like you to do after watching the video, I'd like you to please answer activity 2 and 3. If it's not necessary for you to watch the video, you can use your knowledge that you have built with electrical circuits and answer them using that knowledge.
If you're interested in experimenting with sound and electronics, this simple circuit is a good place to start. I'll also demonstrate how to create some unusual sounds with this circuit, including how to build a device that controls tones with light. At the heart of this project is a readily available and inexpensive integrated circuit, a 555 timer. These devices are available from most electronic supply stores, often for less than $1. Completing this project requires some knowledge of electricity and electronic components. Visit our website at hiloroad.com/555 for a series of instructional videos covering everything you need to know to build a circuit like this. In the following instructions, I will assume you have reviewed this material and are familiar with basic circuit construction as well as procedures for working safely with electricity. Only use a low voltage, low current battery to power this project. Let's build this basic tone generator. This is the circuit diagram for our circuit. You'll find this diagram at our website. Plug a 555 integrated circuit into a breadboard. Let's start by connecting a wire from pin 2 to pin 6. Now resistor R1, a 330 ohm resistor, from pin 2 to pin 7. Next, another resistor, R2, a 2200 ohm resistor, from pin 7 to the positive power supply line, the red line. Next, we need a 1 microfarad capacitor, C1. This connects from pin 2 to the negative power supply line, the blue line. Watch the polarity, positive to pin 2. Next, we need a wire from pin 4 to the positive power supply line. We're going to drive a speaker from pin 3. This means we have to connect a 10 microfarad capacitor from pin 3 to an unused row on the breadboard, like this. Watch the polarity, positive to pin 3. The next 2 connections require a wire from pin 8 to the positive supply line and another wire from pin 1 to the negative supply line. You will need a speaker. I removed this one from a small set of computer speakers. Your speaker may be polarized with a plus and minus symbol on the connectors. Speakers are connected by 2 wires. For our circuit, 1 wire connects to the negative end of the 10 microfarad capacitor. This is at that unused row. The other wire connects to the negative power supply line. We're ready to connect our power supply, a 9-volt battery. Do not use any power supply larger than a 9-volt low current battery like this one. Be careful you don't touch the 2 leads of this battery together. Even a small battery like this can cause burns when short-circuited. Connect the battery to the supply lines with correct polarity and you should have a tone. We can change the frequency of the tone by changing C1 or R2. Let's change the resistor, R2. If we change R2 to 1000 ohms, the tone sounds like this. Change R2 to 3300 ohms, and the tone sounds like this. This 33,000 ohm resistor creates this tone. If we leave our original 2,200 ohm resistor in and intermittently connect a 1,000 ohm resistor across it, we get this emergency vehicle siren. You can create a simple keyboard by connecting a string of different resistors along the positive supply line. Remove R2 and connect a wire to pin 7. Connecting the other end of that wire to the resistor creates this sound. This is a potentiometer, a variable resistor. Turning the shaft produces a resistance from 0 to 10,000 ohms. Using it in place of R2 produces this tone. Pencil lead is often made from graphite. We can use graphite to create a resistor. Draw a heavy pencil line, then replace R2 with 2 wires. Sliding the ends of the wires across the pencil line creates a wide range of frequencies. There are also resistors available that vary with light. You can use an LDR, a light-dependent resistor, in place of R2. Use your hand to block the light falling on the LDR. Sounds like this. Build 2 identical circuits and you will get some richer sounds, a result of the harmonics and beat notes that come from blending 2 different frequencies. If you build 2 circuits on the same breadboard, you may have to connect a large capacitor across the power supply lines to filter and stabilize current delivery to the circuits. Building and experimenting with circuits like this is good training for a career in electronics or computer engineering. You'll find more electronics projects at our website, hylaroad.com. Follow the project's link.
Grade 6s, I hope that you enjoyed that lesson and that you have these notes in your workbook. Please make sure that at the end of this lesson and at the end of today, you've got all these notes written down in your workbook. And then I would please like to ask you to complete activity 3, number 2 and 3 on page 139 in your workbook. Now, if you do not have your Natural Science and Platinum textbook, I have uploaded a scanned version onto Google Classroom, as well as in the last slide of this video, the activity is there. Now remember, you do not need to build the circuit, as I will be putting as you watched the video, you can use that to help you, or you can use your knowledge of circuits in the many lessons that we have been doing to answer these questions. I hope you all have a wonderful day further.